Hello everyone, my name is Hassanur Rahman and the task I have taken is to predict the optimum number of clusters from the given data set iris. So before getting into the part of solving it, let's look into what exactly is k-means cluster. So k-means clustering is a type of unsupervised learning which is used when you have unlabeled data. The goal of this algorithm is to find the groups in data with the number of groups represented by variable k. So k-means clustering helps us to not only group but also gives us the number of groups the data has to be divided into. So yes, so now let's get into yes. I'll start by installing the packages. The packages I've used is stats, ggplot2, ggfortify, dplyr, factoextra, and nbclust. So let me run these packages first. Yes, now that I've run, I've set the working directory, it's in B, and I've named my dataset as class. Yeah, exactly. So now let's view this. We have see here we see the sepal length is in centimeters, sepal width is in centimeters, petal length in centimeters, petal width in centimeters, and the species. You have the three species: Setosa, versicolor, and virginica. Yeah. Let me now run the structure. Yeah. So you've given 150 observations. It even gives us the numerics and character, the class of each one here. And let me run the summary. As you can see, the summary, it gives us a detailed summary of each one here. You have the minimum, the maximum, the median, the mode, sorry, not mode, the quartiles, the median, exactly. And now let's get to the part of, now we're going to determine the optimal number of clusters. We're going to use the elbow method here. So the data set, I've converted into a matrix. Let me just run it. Yeah, you can see it's in matrix. And now let me run the code. We're going to use the k-means test within the sum of squares, right? Let me run this, and now let me plot this. Right, yeah, so we've got the graph. Now we're going to look for the elbow, right? The elbow is right before it goes flat. Now, yeah, we can look at the graph here, but one of the methods we can even use the NBC lust. Now NBC lust here, 1 minute. Yeah, so perfect. So now NBC lust here helps us, this package helps us. 11 propose 2 as the best number of clusters, 11 proposed 3 as the best number of clusters, 1 proposed 8 as the best number, and 1 proposed 12. So according to majority truth, so yeah, so we've got the best number of cluster is 2, right? Now what we're going to do is we're going to use the NBC lust. It has different, we'll visualize this, we'll visualize it right now. So the first method here we've used is WSS, also known as within sum of squares. We're gonna use, we're gonna plot this right now. It's the same thing as what we had before, as you can see, but this one has an x-intercept to it. So yeah, it's very nice to look at it also. So next one is gap stat, right? Now gap stat, we let me run this. It's the, yeah, so gap stat is where we look at when it goes up, right? So that would be the primary one. So here we can see 2 is where it's going up, and that is the primary one. The next one here we can see is 9. Yeah, so the first one we can see the 2 is the first place where the graph starts to go up, and hence that is the most optimum number here. And then let me run the silhouette method as well. Now the silhouette test, it tells how each object lies within the cluster. A high average silhouette indicates a good cluster. So we can see the 2, right? 2 is where, and after that it starts going down. So again, from all the 3 tests we can say that 2 is the optimum number of clusters in the given data set iris. Yeah. Thank you for watching.